Hello guys, welcome back to another USACO problem. I've been pretty busy during the weekends, so that's why I'm making this at 9 o'clock on Sunday. Can't zoom up to my face cam right now because it's very blurry. I need to get a new face cam. Anyways, let's get straight into the problem. So today we're going to be doing the 2017 February contest silver problem. Why did the cow cross the road? Number 3. In this problem, we're going to have an n times n grid of fields. And we're also going to have a bunch of roads connecting adjacent fields. Adjacent as in up, down, left, or right. And we're going to have k cows on the fields. A pair of cows is distant if they need to cross at least one road to reach each other. And our job is to find the number of distant pairs of cows in the whole field. Now that we know the problem, let's jump straight into sample input. So in the sample input, I've already drawn my field, and I used X's to represent the roads because we're trying to find the pairs of cows that are isolated by the roads. So roads kind of serve as a barrier in this case. I also have my cows as white dots in the field. And for this case, we just have two pairs of isolated cows, this and this. And these two pairs are isolated because, as we can see, this cow is all by itself and it cannot move anywhere without crossing a road. So these two cows are going to be isolated to this cow, thus giving us the answer 2. So this problem requires a technique called flood fill. And if I run flood fill starting on, let's say, this cow is going to kind of like explore the grid, but we can also tell it to not cross any roads. So if we do that, then the cow is going to only explore this section over here. So one solution is trying all the possible pairs and see if they are connected or not. So let's say we select these two cows and we want to know if they can reach each other without crossing a road. Well, we can just perform flood fill on both of these cows. So if I perform flood fill on this cow, we're going to get this whole region, and this whole region already contains this cow. But just to make sure, if you do a flood fill from this cow, we're going to contain the same region, and the same region also contains this cow. So that means that these two cows can reach each other without crossing a road. However, the brute force solution is not usually the most time efficient solution. And for this solution, we're going to have a time complexity of big O of 100 squared for trying all the possible pairs, multiplied by 100 squared, because the grid can be as big as 100 squared. So this would give us O of 1 with 8 zeros. And if you draw some commas, that would be 100 million. Which would technically work, but there is a much more efficient way and I just don't want to risk it. Another way we can solve this problem is just splitting the grid into different groups. So we can start flood filling from any cow first. So let's say this cow. We can flood fill from this cow and we'd get all of these squares. And for each of these squares, we're just going to mark them visited. And we're going to select another cow, say this one. But since this one is already visited, we don't have to flood fill this again because it would just give us the same thing. And this cow's in the visited, so let's flood fill this one. It's going to give us only this. So after all of these flood fills, we can see that we've split the grid into two sections. So in the first section, this big section, we have two cows in that section. And for this little section, we have one cow in that section. And we see because these are blocked off, we can actually just multiply these to get 2 times 1 equals 2. So how do we actually do this with multiple groups? Well, I have a case right over here. In this case, we have 19 cows, and we're split into groups like this. Now let's look at the first group, 5. we have 5 cows in the first group. And in that group, each of the cows cannot reach any of the cows that are outside of the group. So each of these 5 cows cannot reach all of these cows combined, which is just k minus 5. So all we need to do is we need to multiply the number of cows in this group by the number of cows outside this group, which is 5 times 19 minus 5. That's all we need to do. And for the 1, it's the same thing. So we can just add on 1 times 19 minus 1. And we just keep doing this until it's done. So every time we're multiplying the number of cows in the group multiplied by the amount of cows outside of the group. All of this may feel pretty straightforward right now, but flood fill is actually a pretty annoying algorithm to code. So let's get straight into the coding. So first of all, we're going to read in N, K, and R. And then we're going to create our grid. The grid is going to be a 3D array. So that just means a 2D array just like the grid we have here. But in each of these squares, we're going to store another vector. Don't worry, this vector we store in each one will be constant size. So it's not going to be like size n or size k. We're going to store specifically a vector of Boolean. And it's going to store up, down, left, right, cow, and visited. And these are all Boolean variables. So up just means if there is a road connecting up, if there's a road connecting down, if there's a road connecting left, right, and then if there is a cow, and then lastly, if this current grid is visited. So I'm just going to be using a vector for this. I'm not going to be using a class. And first we're going to build the outer wall so that the cows cannot walk out of the grid and give me all sorts of errors. So I'm just going to make some walls. So first we're going to set the up wall, which is just going to be 1 and then for each I, and it's going to be 0 because 0 represents up. Now we're going to do the down wall. It's just going to be ni, and 1 represents down. And then we're going to do left and right, similar to how we did up and down. Now we're going to actually read in the roads and create the other roads that we need to create. So we're going to read in R1, C1, R2, and C2. They're just 2 points. And now we're going to check if R1 is equal to R2. So if the row number is the same, that means the column number has to be different, meaning that it's either left or right. The road is horizontal. It's left or right. In this case, we're going to say the leftmost column is going to be just the minimum value of C1, C2, and the rightmost column is going to be a maximum value of C1, C2. So we get which one is smaller and which one is bigger. Now we're going to say the grid of R1 and the leftmost column, 3 just means right, is true. So we're setting the leftmost column right wall to be true. And we're going to set the right column left wall to be true. Okay. Now, else it has to be up and down, so that just means the rows are different and the column stays the same. Similarly, up R is going to be the minimum of R1, R2, down R is going to be maximum of R1, R2, and we're just going to say the one on the top, we're going to set the down to be true. So there's a wall or road going down. And we're going to set the down one, we're going to set the up road of that to be true. Now we're going to read in the cows. This one's the most simplest. We just say grid RC, that's just the row and the column for the cow. 4, which we set here, is cow. I'm going to say equal to true. Okay. Okay, now we're going to actually do the flood fill. So we're going to set our result to be 0. We're going to keep adding to this result as we go. We're going to cycle I from 1 to n and then j from 1 to n. And in each of these, we're just going to say if it is visited, then we're going to continue. If it's visited, we're not going to do anything else. We're just going to keep going. And now we're going to use queues to do the actual flood fill. So we have qi and qj. Qi is going to store the I values, and then qj is going to store the j values, or the column and the rows. So we're going to first push I to the qi and push j to the qj, because that's our first cal that we need to start with. And we're going to say the visited to be true. The cal count is just the cal count in the current group. While qi is not empty, we're going to read in the current I and the current j. Cal count plus equals grid current I, current j 4. That just means if it is a cal, then we're going to add 1. If it's not a cal, then we're not going to add 1. Now we're going to check the up, down, left, and right and see if we can go there. So how do we know if we can go up? Well, we first check if there's a wall. So if there is not a wall or not a road, we can go up, and it has to be not visited. So if there is not a wall and it is not visited, then we can go up. So to go up, all we need to do is we're going to add the I value to the qi. So current I minus 1 is going to be representing up, because we're minus 1 to the column. That's going to be up. And qj dot push current j. So we also put in the j value. Then we just set the visited to be true. And down, left, right is going to be pretty similar. All we do is we're going to say if there is not a wall and if it is not visited, then we are going to push the index into the queues, and then we're going to set it the visited to be true. So all that is different here is list plus 1, because I plus 1 is going to be down, and I plus 1 here as well. Then j minus 1 is going to be left, and j plus 1 is going to be right. That should be our flood fill. After that, we have our desired cal count, and we're going to do our algorithm that we talked about earlier of multiplying by the k minus the cal count to add to the result for this group. Then we also, I didn't say this before, but we also have counted 2 times for each pair, because if we think about it, if we have one group, so if we have one group going here and this group went here, that would be 2. But after that, we're going to cycle from this group, and this group is going to be also counting this. So that actually kind of gives us 4. So we need to just divide everything by 2 to get everything without repeating. Okay, that was a lot. The algorithm for this problem is actually not that complicated. It's just the coding might be a bit annoying, and it could be easy to make a mistake on. And that's probably why this problem is problem 3 for this contest. Hope you guys enjoyed the video, and I'll see you in the next USACO problem.